this is the presentation for this towards Urban Analytics 2.0 in Leeds. And today I will present the topic of the identifying tree preservation order by using multi-source deep learning in Greater London area. And my name is Qing-Shan Zhao, and I'm a lecturer in Urban Analytics based in Urban Big Data Center and University of Glasgow. So just want to give you some introductions for this research. And at the very beginning, we got contact with one of the company collaborators, and they are kind of real estate developers, and they're really interested in how to identify the tree preservation order to avoid the problems in their planning application. But it ended up with, we found out this is actually a pretty interesting research question as well. It's like how we can identify the TPO more efficiently and to provide more benefit for the entire society. So the tree preservation order is used to protect the specific trees from damage and destruction. And in the UK, the TPO usually requires 3 conditions. First one is the visibilities. Second one is basically the cultural and historical values of the trees. And the third one is really about the contribution of the trees to the surrounding landscape. So you can think of the TPO is more like a social attributes of the trees. But right now in the UK, the TPO trees are managed in a very low capacity and in the UK, and it is really a barrier for both for the environmental protections as well as the urban development. So here are some examples of the TPO trees from the satellite images. So the research objectives for this talk, or say this research, is really just to build a multi-input deep learning framework for the classification of the TPO or non-TPO trees to simplify the identification process. And we use the study area in London, so you can find out after we try to look at the TPO trees in the London area, there's only about 6 areas with this kind of dark green color. We have the downloadable TPO coordinates for each of the trees. But for a lot of other places, either we only have an online map, or maybe you only have a text tables, or maybe you even need to apply to get it, or maybe even just to talk with the local staff and see if they have a local copy of it. So that's difficult to get. And for the methodology wise, the first thing is that to identify TPO trees using a deep learning algorithm, we need to have some ground truth data, right? So the ground truth data we use is really the TPO data we got from the London local boroughs, the 6 local boroughs we got. And then we use the tree canopy information from the Digimap and also some of the London open data. And the aerial images we use to classify through the Digimap as well. And we also obtain, some of the road network information and also the IMD to represent the socioeconomic data. So the pre-process, we do the GIS spatial analysis, and then to actually find out where's the tree canopy images, as well as the tree geographical and socioeconomic attributes, something like a distance to green space, distance to blue space, the road network, and also the IMD, something like that. And in the deep learning framework, we combine the ResNet 50 version 2 with the multi-layer perceptron and the long short-term memories. So for the ResNet 50 is really help us to extract information from the images, from the aerial images. And then the multi-layer perceptron is to actually combining those kind of more traditional socioeconomic variables into the model. And then we combine both data set in one, say, deep learning framework. And the final thing is to use the network to predict the TPO or non-TPO trees. In the results, and you can find out, so by only using the image data, we can get about 85% of the accuracy. And if we use just the geographical and the socioeconomic data, we get about 84% accuracy. And if we combine both data, with the multi-layer perceptron plus the ResNet 50, we got about 87% of the overall accuracy. And with the 0.935 of AUCs and relatively low the test loss. So basically, the multi-model network really works for us to achieve the best result. So some of the discussion conclusions, by doing this, we really proposed a new deep learning framework to help classify the social attributes of the trees with a high test accuracy. And which is more efficient and low cost than a very traditional survey methods. If you send someone to the site and to look at which trees should be the TPO trees, something like that. And we really, I think that first part of the data collection, we really figure out in the Greater London area, the TPO data is really in a poor digital format. It's not really analysis friendly. And we really need to think about how to improve the TPO data set in general to help us understand more of the social aspect of the trees. And I would say to kind of bigger pictures that it really helps improve the data management and work efficiency of the government, reduce the cost for real estate developers because they can avoid those trees in the planning application, save a lot of money, save a lot of time. And it also really helps the environmental organizations to monitor and protect the valuable trees. Some limitations in the analysis. The first thing is that we use a fixed size circle to crop the images. And the problem is that if we have a continuous trees, you really cause the duplication really at the edge of the image. And the TPO data is really accumulate over time. So you can have something like 10 years ago identified as TPOs. 20 years ago identified as TPO, but we use the latest area images to do the classification. So they might be mismatched because the trees are always growing, right? The third one is by considering the complex social attributes of TPO, we may want to still adding more information to help us understand how to better classify the TPO and how to extend this practice to a wider say context. So maybe not just UK, but the Europe or other places, that would be something interesting to do. That's pretty much for this talk. And here's my information. Feel free to email me, send me questions. Happy to answer any question you have. Thank you so much.